2D-BP was tasked with designing and producing a system to remove dye from wastewater, in congruence with new EPA regulations. Listed below are the specific criteria for our design. These are the materials chosen for our filter. They consist of structural components, filtration media, and aesthetic pieces. PVC, or polyvinyl chloride, is a cheap, easily to produce synthetic plastic. We chose it for its strength-to-weight ratio and low cost. Aluminium oxide and activated charcoal were chosen due to their properties of adsorption, enhanced by their huge surface area, both over 500 square meters per gram.
In our quest to make 2DBP Filtration Services the most efficient and effective producers of water filters in all of UConn engineering, we have made many iterations to our original filter design. These iterations include changing our structure design and the filtration process. As shown in Phase 1, we went from a flimsy Dasani water bottle to a firm, stable, Honest Tea water bottle fit for any filtration device. We also added cheesecloth to our housing and removed the glass beads from our media so that our filter may perform at the highest of standards. And to finish it off, we added a paper sleeve displaying our company's name, designed by our very own Andrew Berman, to give our filter that sleek, quality look.
Now, we are going to take a look at the inner workings of our filter, the thoughts behind our choices. On our initial meeting as a group, our first goal is to decide upon a structure. Before we could ever filter water, we needed a structurally sound system to have an unassisted standing water filter, and we found our answer in a water bottle. With the help of a nearby vending machine and the dying thirst of my group member Joseph, we produced an empty water bottle and our filter basis. Using a single water bottle as the whole base of our filter provided a freestanding structure at very little expense. Separating the bottle into sections, we had a mouth at the top of the filter for the housing the rest in, and a cup, or as we refer to it, a chalice, to catch the filtered water at the bottom end. From here, we utilized a housing tube for holding the media. We decided upon the 1-inch diameter rather than the 2-inch. The 1-inch allowed for the media to be more packed, therefore the dirty water would have to travel through more media. The addition of a paper cup came later, adding necessary height as to allow the bottom of the housing to be sitting above our cup, which catches the final product. The cup also provided more support to the filter, making the structure very rigid and guaranteeing the freestanding aspect. For the photometer, we utilized leftover pieces from our filter structure, hence spending no extra money. Plastic mesh formed into a cylinder with a top and a bottom, lined by the black sides of duct tape, created a housing for our LED and photometer sensor, where light absorption readings could accurately take place. For our LED, we implemented the tricolor RGB bulb. With the simple input of the user, the color of the bulb could be red, green, or blue. We strived to meet this goal not only because it was a stretch goal of the filter project, but because having 3 lights and gathering data would determine which color would pass through our filter water the best, giving us the best results from our photometer.
Our overall performance was fair. While the filtered product was red, the photometer read the concentration to have reduced to 1/16 the original. Reflecting on this task, we would have made a few improvements. One improvement would be to adjust the housing so that the LED and photosensor were always aligned with the cuvette. This would allow a better reading. Another idea was to rid the housing altogether, as our cost would have been cheaper and the mass and structure smaller. Adding pebbles may have also been beneficial, allowing the dye to rub off on a coarse surface. We would have also liked to cool the water, as research has shown that cooling water increases charcoal efficiency.